Hello everyone. Today we are going to look into the unit number 4 of environmental studies. The topic is energy. Let's see what we are going to look into these topics. We are going to learn on energy and its significance, different types of energy. In this video lecture, we'll be learning on conventional energy, that's also called as non-renewable energy. In my next video, I'll be discussing on non-conventional energy, which is also called as renewable energy. So here we are going to learn conventional energy, which is non-renewable energy. In this particular video lecture, we'll be learning on. Before we get into the topic, I'll see the objective that we are going to learn, the objective that we're going to focus upon. Here, we would like to know the history of energy usage. Let's understand how the sources of energy are used worldwide as well as in India. To understand various non-renewable energy sources that are available to us, how it is being used, and its extent of usage. Let's also highlight the merits and demerits of non-renewable energy sources. Then we'll move on to the next topic in the next video, that's non-conventional energy or the renewable energy. Energy, by definition, you can say it's the capacity to do the work, and it's a vital thing that's required for life process. All energy resources is something that can produce heat, power the life, move the object, or produce electricity. The basic fundamental things that is happening worldwide in the humankind. The first of the form of energy that was known to human is fire. So the humankind learned from the fire that energy is existing. Then it went on now to the latest technologies that are available to harness the power of energy. Now the energy, when you say, we hear a lot of terminologies like joule, BTU, or kilowatt hour, or kilocalorie, calorie. So let's just look into that particular aspect. It's nothing but the units of energy, different forms in which the scientists or people or engineers use these numerical values along with the unit. Just have a look at it, that 1 joule is equal to 4.1886 calories, or simply you can say 1 calorie is nearly 1/4 of a joule. That is roughly you can say 1 joule is nearly 4 calories, 1 calorie is 1/4 of a joule, that is 0.24, that's 25% of a joule, 1 joule. 1 BTU, nothing but 1 British thermal unit, which is equivalent to 1055 joule. What it means is, you take 1 liter of water, you try to increase the heat or the temperature of that water by 1 degree Fahrenheit. How much amount of energy you require in terms of joule is called as 1 BTU. So that's how a basic definition you can think of. Then we have another unit, kilowatt hour, which is usually used in the energy consumption in the form of electrical energies. So let's look into that aspect in a while. Let's look at the history of how the energy is used. First, the humankind began with fire, then the coal. Coal and fire known to human being times since time immemorial. So after several decades, several centuries, the human invented the steam engine. After the steam engine, industrial revolution has taken place. Then the energy has taken a big leap. Now we are using energy for different sectors. Almost you cannot imagine any sector without use of power or energy, like aeroplane or a bullet train or the buses or any plant industry or any company, could be a domestic purpose, or the latest one, the robotic factories. So all the form you require energy, and this is how it has begun. In the beginning you required a low quantity of energy, and only few types of sources were discovered and used. Later on we are moving on to the different sources of energy because the requirement has increased. So you have two main different types of energy based on its availability and usage. We call it as non-renewable energy. Also we call it as conventional forms of energy. Conventional forms, why we say, because we have been using that from long time, and the technologies that we require for that is existing, and it is non-renewable because you cannot renew it easily. It takes a lot of time to produce that particular fuel, and in our time period it's really difficult to get that particular sources of energy back in its original form. Whereas renewable energy, it is being produced by sun over the time. Because of solar energy you have a lot of other energies, we call it as wind, geothermal, water, biomass. So it gets produced, but the problem is we do not have a readily available technology for its large use, large application. So it is being used in a significantly smaller scale. That is why we call it as non-conventional energy or non-conventional sources of energy. So the energy source is a natural resource that human use to generate energy, and it can be renewable or renewable, as we have seen. So the non-renewable energy resources, or we call it as conventional sources of energy resources, they are used faster because we use them regularly, and large section of our usage is from these particular resources. So they cannot be, it's very difficult to replace them because of its usage speed. Example, we have fossil fuel and nuclear energy. These are the main two types of the non-renewable sources. Fossil fuels, we have solid type coal, liquid type crude oil, and the gaseous type natural gas. So in this video lecture, we will be focusing on these two types, fossil fuel and nuclear energy. In my next video on renewable energy sources, so we'll be looking into the different non-conventional sources of energy there, like solar, wind, geothermal, bioenergy or biomass, tidal energy. So let's move on to the non-renewable resources. In the time being, let's look into the various sources of energy. Let's look into the global scenario first, how it's being used. You can see here that oil, coal and gas, they made up the fossil fuels, and it comes to around 85% of the global energy. That's a large section, and a small section is for the renewable energy, which is a non-conventional energy. A small section is used worldwide. So we still depend upon the non-renewable energy sources by large. Now when we use it, it is forecast that we used the 1973, for example, about 3-4 decades back, we were largely dependent upon the non-renewable energy sources. Over the time, because of the environmental acts and other policies of the different governments, there has been a large increase in the renewables, and by 2040 it is expected that renewable energy would increase production and the usage of non-renewables will be reduced. So for example, the case of oil, the percentage of its usage will be reduced. Natural gas obviously is likely to be increased because of its abundance and the availability. Coal, there will be a reduction. Nuclear would be increased. Renewables will be increased. So it depends upon how it is impacting the environment also. That's also one of the factor. Now let's look into the Indian scenario. So in India, we are largely dependent upon the coal, which is 55% of our entire capacity. So then comes the renewables, which is 24%, and we have hydropower, natural gas as the sources. Now when you go to the capacity, that's the production from various sources, right? So we have coal, which is coming to 55%. We have 205,135 megawatt. So we have around 370,106 megawatt installed power capacity, of which the large portion is for the coal, as it is seen here, 55% roughly. So we have different forms of energy being used in India, but there is a significantly lower quantity compared to the nuclear powers or even renewable energy. We have, it's a combined different types of renewable energy which needs to increase over the time. Now in India, sector wise, we'll see the consumption, how the crude oil is consumed. We largely use the crude oil for the transportation, which is 37%. Then industries and residential usage is taking place for the crude oil. Then come to agriculture, power sectors and other sources, maybe commercial. So in India in 2020 it was total to around 880 MTOE power demand. MTOE means millions of tons of oil equivalent. That is 1 million ton of oil would be used to produce that much amount of energy. Now, in India, the power generated, it was around 138,000 gigawatt hour. That is one of the almost meeting the requirements, demands of the of India over. Pan India requirement is less than that. So we are self-sufficient, but the problem is we are procuring the raw materials that the resources required from outside. We depend upon imports. Let's look into certain aspects of these different fuels, how they are formed. For example, the first one, the coal, a solid fossil fuel. Coal is formed from the remains of the plant. So what happens is, long ago, 300 million years ago or so, the plant or the living materials, they were buried under the ground, but are buried under the earth layers. Over the time, the sediments have deposited over that, and the first thing that happened was coalification process. The first thing that would perform was lignite, a soft coal. Over the time, because of the temperature and pressure, when it is buried down under the earth, there will be a lot of pressure applied on that. Since it is at the bottom nearer to the core, the temperature of that particular layer will be very high. Because of that particular high temperature, the water gets evaporated through the permeous rocks or semi-permeous rocks, and more solidification takes place. So the lignite is converted to bituminous, converted to anthracite. So you have three different forms of coal, that's lignite, bituminous and anthracite. In this particular order, the moisture content reduces and the quality of the coal increases. So you can say anthracite is the black coal, hard coal or very rich coal source. Whereas the brown coal, which is also called as soft coal, the lignite, is less energy intensive coal. That's a raw coal. So coal is mostly made up of carbon. There are some elements of hydrogen, sulfur, oxygen and nitrogen. So you have a steam engine that was invented in 1850s, and there the coal consumption was made use of for running the steam engine, and that's the point. That's the tipping point where the revolution has taken place. After that, industrial revolution has taken place. So those are all the tipping points where the usage of coal has increased. But the coal mines were used or known from time immemorial. One of the largest consumer or the importer of coal is China. Even they have producers also. That they are the topmost producers. A lot of coal mines are there in China. They produce, I believe, around a half of the world's coal resources. India stands second in its consumption, but the 10th position in the world production. So we import coal. Australia accounts for about one third of the world coal production, and also we have Indonesia, Russia that produce coal. If you look at the emission intensity, how much amount of carbon dioxide it can emit, yeah, that's true. It produces a lot of environmental concern. Carbon dioxide production is there. So imagine you have used coal to produce 1 kilowatt hour of energy. Meanwhile, what you would have done is you would have produced 1000 gram, that's 1 kg of carbon dioxide, and released to the atmosphere. Now, energy density of coal is, you take 1 kg, you have 24 megajoule, or you can call it a 6.7 kilowatt hour. So nearly 40% efficiency is there for each coal power plant. So it cannot go beyond 40%. That's the limiting factor for the coal power plant, which is one of the disadvantage or the demerits of this particular process. So representatively, I can say that one coal power plant to produce energy sufficient to light one 100 watt bulb. Imagine you light it for one full long year. You require 325 kg of coal. That's a big number, right? So you are making a lot of energy intensive process to burn it and then produce little amount of energy, and meanwhile you are making environmental pollution if we use coal. So that's the reason why the usage of coal is uh, projected to minimize. So you have the bituminous coal, which approximately has around 84.4% carbon and rest around hydrogen, nitrogen, sulfur on its dry weight basis. Mostly the coal is used for electricity generation. Also we have it for the cement and steel manufacturing plants, where coal is used as in a furnace for generation of the heat. So otherwise 68% is for the electricity generation. Now how does it work? We have a furnace coming into picture here. Into the furnace it is burnt. The coal is burnt in a furnace. Water is used to supply through that to the pipes. It gets heated up. The heated water becomes a steam and turns a steam turbine, generating the electricity and providing it to the grid. So let's move on to the next topic, crude oil. Crude oil is a liquid mixture of complex hydrocarbon compounds. You get diesel in it, you get petrol in it, you have LPG, liquid petroleum gas, you have kerosene, naphtha, fuel oil, tar, and many more. So these are all the compositions of the crude oil, which is also called as a black gold. It's dark black in color. How it is processed? So first it is drilled from the resources, that is a deep earth resources. It is drilled first, then it is refined, and after that, after you do a refining process, you get different types of the products like diesel, petrol, LPG, and many more, the pure ones, which we generally use for the which we generally use in the transportation sector or any other sector as it is or in a modified form. How it is produced? It is also produced under the sedimentary rocks similar to the coal, but the difference here is you have the traps that are formed along with the water where the oil remains as it is. So the over the time this hydrocarbons which is present in the animals, that is living beings, that are sedimented below the rocks, impervious rocks, because of the high pressure and temperature, the oil gets deposited over there. Because of the impervious nature, the moisture cannot be removed, and over the time, because of the anaerobic process there, they get degraded. The hydrocarbon get degraded and formed into the oil form. Because of the high temperature present there, the gas may be produced, which we call it as natural gas. So crude oil and natural gas are produced with the same mechanism, and from this particular location the wells are bored, which is about 40,000 feet deep earth, 40,000 feet deep earth, which is larger than the Himalaya mountains. So it is drilled and the crude oil is obtained, and then it is refined in the refineries. So the refineries come into picture in the next stage after it's drilled. So you have the crude oil, it comes to the furnace. You have the crude distillation unit as well as vacuum distillation unit. Based on the temperature of its boiling, they are separated. That's called as fractional distillation. They are distilled off because of boiling point. And fractionation means you are making into different fractions based on its carbon compound, and which is dependent upon their boiling point. So you have different products like gasoline, we call it as petrol. Otherwise you have the jet fuels, you have kerosene, you have diesel, you have thick lubricants, that's lube oils it is called. So you can make use of these solids that remain at the end. You can call it as bitumens, used for the road manufacturing, processing, or you can have it for the lubricating oils or the diesel engines or the jet oils or the gasoline for the cars, or some chemicals, even LPG, liquid petroleum gas. So for that also it is used. So let's look into some fraction figures for the crude oil. Petroleum oil, it's also called as rock oil, which is in Latin. The hydrocarbons are mainly alkanes, cycloalkanes, aromatic hydrocarbons. Mainly it is made up of carbon, that's around 85%, and nearly 10% of hydrogen. Oil was known long ago in China, but the systematic recovery using a refinery was built in 1856 in Romania. In India, Digboi refinery in Assam is the oldest operating refinery in the whole world. We have something called OPEC worldwide, known as the Organization of the Petroleum Exporting Countries. Organization of the Petroleum Exporting Countries. There are about 15 countries here. They are the consortium of countries that produce petroleum, crude, and export to other countries. Not every country is a member of it. Usually the Middle East are member of it. Most of the Middle East countries are part of it. As on today, the top 5 oil producing countries are USA, then followed by Russia, second position, then Saudi Arabia, Canada, Iraq. Here Iraq and Saudi Arabia are part of OPEC. Top importers of crude oil in India. This is for the India. India imports, the importers are like from global, from these producers. China is importing the oil, number 1. Second is USA, then India, Japan, South Korea. Now India is the top third importer of crude oil. Now let's look at the scenario how we are procuring it. We are not procuring from one single country. We are procuring the crude oil from different countries. The majority is from the Middle East, which is 59%. So the Middle East is our main resource for the petroleum resources, that's crude oil resources. The Iraq is number one, next followed by Saudi Arabia. We also have from United States, then African countries also. The oldest operating oil reserve in India is Digboi in Assam. The largest oil field in India is Bombay High near Mumbai. There are about 159 rigs and drilled 545 production wells. The oil wells, we have around 159 rigs. Then even if we have this much, we are less than 1% of the world production. That's 0.96 percentage production we have compared to world. ONGC, Oil and Natural Gas Commission, is the leading government sector unit. In fact, it's a public sector unit now. So that is producing, looking after oil reserves, major of the oil reserves in India. Oil refineries, the oil reserves come to the oil refineries for fractional distillation. So total we have 24 crude oil refineries in India. Of this, 18 are state-owned, 3 are private and 3 are joint ventures. The largest among them is Jamnagar refinery of Reliance Industries. The nearest to our place, that's MRPL, Mangaluru, we have that's run by ONGC, which is the fifth among the 24. So the next one is the natural gas. It is mainly composed of methane, which is more than 80%, and it's odorless and colorless. Mercaptan is added to it so that it gives the odor. If there is a leakage of the natural gas, you can identify because of that particular smell. Both oil and natural gas go through the same process of formation as it is mentioned earlier for the crude oil formation. So the difference here is you have the gases that are produced because of high temperature. Earlier in the previous case of crude oil, the gases were not formed, it is in the liquid form. So that's the major difference that happens in the formation of natural gas and crude oil. Natural gas can be used for residential purpose, commercial purpose, industrial purpose, or electricity generation or transport, industry or domestic. Most of the energy from natural gas in India is used for, that is the power generation, and equivalent amount for the fertilizer industry. Rest you have a domestic fuel usage, power generation for petrochemicals and other usages. The global producers of natural gas, the top is by USA, Russia, Iran, Canada and Qatar. Next we have a nuclear energy. This is another type of non-renewable energy. Nuclear power is the use of nuclear reactions. So there is a nuclear reaction taking place that generates heat. So heat is generated as the end result, which most frequently is then used in steam turbines to produce electricity. The heat generated over here, because of the thermal energy that's produced, you can make use of that heat to boil the water and generate the electricity using steam turbine. Now there are three main types of the nuclear power you can think of here. One is nuclear fission reaction, nuclear decay and nuclear fusion reaction. Of this, the most common ones are the nuclear fission reactors. Uranium U-235 or plutonium-239, these are the two mainly used nuclear fuels worldwide. What happens? You have a decelerated neutron starting the chain reaction. The chain reaction further ends up with the fission of the nuclear components. You can have iodine, xenon, cesium as a byproduct. Then further the neutrons that are produced as a byproduct of this, they further react with uranium-235, initiating a long chain reaction. A lot of beta particles, gamma rays, they are also produced along with the heat. So you require care, a lot of care when you use nuclear energy, or otherwise this could be lethal, or it could end up in disasters. So you take a nuclear power reactor, you have the nuclear reactor vessel which is completely shielded so that the nuclear decays, or there is no nuclear energy, that beta particle or gamma particles are not escaping to the surroundings. So you can supply the water, usually brine is supplied through this particular casing, and it gets heated up. The hot steam is used to turn the turbine, and then the generator, the electricity produced used for the grid purpose. So this is recycled. There is something called as control rod, so that you can control the power supply. The energy generated required may be a limited value. So, but the power generated over here could be very large. To control, you need to control the entire process. Here you will be using control rods. Control rods such as boron, made up of boron, cadmium, silver or indium is used. They absorb the neutron which is produced over there. By that they can control the entire chain reaction. So this is one of the reactors in India. This is how it looks inside the entire reactor setup inside. India is 6% of world's energy production in the form of nuclear energy. The leaders are the US and France, China, Japan. All these account around 50% of global generation. India stands 13th in this list after US, France. India has 22 nuclear reactors, of which were operating in the 7 nuclear power plant, which is already commissioned, and in Gorakhpur it is being constructed. So we have Kakrapar, then Kaiga, Kudankulam, Kalpakkam, Narora, Rajasthan, and Tarapur operating nuclear power plants. So Baba Atomic Research Center, BARC, it commissioned Apsara named first nuclear research reactor in India, which is also happens to be the first in Asia. Then Kakrapar Atomic Power Station, which is in Gujarat, it is the largest nuclear power plant in India. Kazakhstan and Russia, these are the major suppliers of nuclear fuel to India. India has a domestic reserve recently found in Tumalapalle belt in Andhra Pradesh and Bhima basin in Karnataka. So these form the domestic reserve for India's nuclear power. So we have a lot of merits and demerits of using the conventional source of energy. Even they produce a lot of energy cheaply. The technology is readily available for us, easy to transport, and a full range of application. So you can use this energy for anything. Nuclear fission produces large amount of energy and no air pollution because of nuclear fission. But at the same time, we have a lot of demerits. That is, the resources are exhaustive. They are non-renewable. Burning of the coal, it produces sulfur dioxide and leads to acid rain. The coal mining, it disturbs the habitats and pollutants. It pollutes the water. Oil associated with occasional oil spills damage the environment. Burning the fossil fuels produces smoke, carbon dioxide, and greenhouse gases. Nuclear power plant produce dangerous wastes that remain radioactive even after thousands of years. So waste disposal is the biggest challenge in nuclear power plant. Also, harmful radiation may be released into the environment accidentally. So accidents we need to look into. So let's just have a quick look on the case of accident. You can just Google through these particular cases. One is the case of Fukushima Daiichi nuclear power plant recently happened in 2011 when the tsunami and earthquake together it took place in Japan. So currently this particular nuclear power plant is shut. The old example we have from 1986 from Ukraine, the Chernobyl nuclear power plant. So you can look into this particular example in the internet. Coal mines, they are not far away from the accident. There are about 279 major accidents that have taken place from 1907 to 2007. A lot of deaths have taken place, and it's quite common to have deaths in the coal mines because of the carbon monoxide and low oxygen level at the D levels. You have oil spills in the oceans. The best example is the Persian Gulf War oil spill, that is in 1991. Deepwater Horizon oil spill by British Petroleum. The Stock 1 oil spill in 1979. In India, we have Assam gas and oil leak in 2020. That was because of the natural gas blow out there. And we have Mumbai oil spill because of the collision between two cargo containers. So these are all causing the damage to the environment, which is quite common case in the case of conventional energy. In my next video, we'll be looking into the renewable energy sources. Here we have seen all two main different types of the non-renewable energy sources, that is fossil fuels and nuclear energy. Under fossil fuels, we have seen three different types of the fuel, that is coal, solids. For liquids, we have the crude oil. Then gas, we have the natural gas. Their merits and demerits. That's what you have seen. That's it for this video. Thank you. Let's see in the next video.